Okay, we're going to finish up section 1.6. We're going to start out with a problem like this, one of these double square root problems. What we need to do is isolate one square root on one side of the equal. So I'm going to take this negative square root of x plus 1 and I'm going to add it across to the other side. That will isolate this square root term that we have on the left-hand side. So we're going to square both sides of the equation. When we square the left-hand side, the square is going to undo the square root, and we'll just be left with 2x plus 3. When we square the right-hand side, though, we're going to have to multiply this term by itself, which is going to require FOIL. So we get 2x plus 3 equals, first to be 1 times 1 is 1. Outer will be 1 times the square root of x plus 1. Inner will be a square root of x plus 1 times 1. And last will be a square root of x plus 1 times itself, which will be a square root of x plus 1 squared. So the square here is going to get rid of the square root there. We'll get 2x plus 3. I'm going to take the 1 here, and I'm going to add the 1 here to it. 1 plus 1 is 2. I'm going to move this square root of this x term here that's outside of the square root now. I'm going to add that next. And then we'll combine these two together. If you have a square root of x plus 1, you add another square root of x plus 1 to it. That gives you plus 2 square roots of x plus 1. So now I need to subtract terms, cross the equal sign, to re-isolate the square root of this part here. So 2x minus x is a single x, 3 minus 2 is 1. That equals 2 times the square root of x plus 1. So we'll re-square both sides of the equation. When you square here, since this is separated by a multiplication, you can square the individual pieces. I'll get x plus 1 squared, which needs to set up for FOIL again, equals 2 squared, which is 4, and the square here undoes the square root there, so we get 4 times x plus 1. So I'll FOIL this out. X times x is x squared. Outer would be plus an x. Inner is plus an x. Last is 1. Here the 4 distributes. And now we'll go through and we'll subtract terms across. So the 4x I'm going to move on over. And the 4 I'm going to subtract on over. So I got an x squared plus x is plus 2x's. 2x's take away 4x's is negative 2x's. 1 take away 4 is a negative 3. So this factors as x minus 3 times x plus 1 is 0. So I get x minus 3 is 0. And I get x plus 1 is 0. The negative 3 scoots across. The positive 1 scoots across. We get x is 3 and x is negative 1. And at this point I got to check my solutions and make sure that they work. So I go to the original equation, which is this. And I got to check if I replace the x's in the original equation, does it give us 1 back? So let's see here. How about x equals 3? When I put 3 in, I would get the square root of 2 times 3 is 6. 6 plus 3 is square root of 9. Minus 3 plus 1 is 4, so that's square root of 9 minus square root of 4. This is 3 minus 2, which equals 1, so this checks out. X equals 3 is a good solution. So let's check x equals negative 1. I put negative 1 in for here. 2 times negative 1 is negative 2. Negative 2 plus 3 is square root of 1. We get minus negative 1 plus 1 is square root of 0. So I get 1 minus 0 is 1. That checks out too. That's good. So I get both of my equations, or both of my possible solutions, end up making this equation true, so they both work. All right, so next up we're still kind of looking at some square root types, or I guess it's really cube root type stuff. So for example 6, we got the cube root of 4x squared minus 4x plus 1 minus the cube root of x equals 0. So step 1 is we want to take this negative cube root of x term, we want to scoot it across the equal sign. So we get this equals this. We need to go through, we need to cube both sides now that we got our cube root part isolated. And we get kind of lucky in this one, we're cubing the cube root. It undoes, cubing undoes both the cube roots, and we just get the inside stuff left. So now we subtract x across. Get 4x squared minus 5x plus 1 is 0. Says 4x x 1 and 1 minus and minus. So 4x minus 1 is 4x minus 1 is 0. It says 4x is 1. Divide the 4 across, says x is a fourth. Or x minus 1 is 0. Says x equals 1. So we're ready to check. So we got to go back to the original form and check and see if I replace the x's with the numbers that we got there. Does everything total up correctly like it's supposed to? Okay, so let's check x equals a fourth first. So we would get cube root of 4 times, a fourth squared is a 16th, minus 4 times a fourth, plus 1 minus the cube root of a fourth. Let's see here. This would be the cube root of 4/16. A fourth of 4 is 1. Minus 1 plus 1 cancel. 4/16 reduces down to 1/4. So this is the cube root of 1/4 minus the cube root of 1/4. And cube root of 1/4 minus itself is 0. That's what it's supposed to equal. So yes, x equals a fourth. That one is good. Let's check the other one, x equals 1. If I put 1 in, I get cube root of 1 squared is 1 times 4 is just 4. Minus 4 times 1 is 4. Plus 1. Minus the cube root of 1. 4 minus 4 cancel. We get the cube root of 1 minus the cube root of 1, which is 1 minus 1, which is also 0. So in this case, we check both our solutions and they both worked out okay. So again, we start here. We isolated, by scooting this term across, we isolated one of the cube roots, cubed both sides, took the remaining stuff, factored it down, got our possible solutions, checked them against the original form and see if they work. Okay, so now we got a couple more to look at. So we got part A here. We want to do x to the 3/5 equals 27. And part B, we want x minus 4 to the 2/3 power equals 16. Okay, so for this first one here, we need to get the 3/5 power moved to the other side. So to do that, we're going to raise both sides to the 5/3 power. 3/5 to the 5/3. This will be power to power multiply, so the 3's will cancel, the 5's will cancel. You'll just get an x to the first power equals, when you have something like this, fractional exponent, 3 tells you the root number, 5 tells you the power. So this will be the cube root of 27 to the 5th power. Cube root of 27 is 3, so this will be 3 to the 5th power, which is 243. Okay, now on this other side, since 3 is the root number here, 3 is the root, and we're undoing a even power, we're going to get x minus 4 to the 2/3 equals 16. We're going to raise both sides to the 3/2 power. This has you undoing an even power with an even root. When that happens, you need to put a plus or minus in front of your solution here. So these two will cancel. We'll get x minus 4 equals plus or minus, the root is second, so this will be the square root of 16 to the 3rd power. So this will say x equals, the minus 4 will slide on over as a positive 4, plus or minus square root of 16 is 4, so this will be 4 cubed. So x equals 4 plus or minus 64. So this is going to tell me there's two solutions here. 4 plus 64 says x is 68, or 4 minus 64 says x is negative 60. Oh, I should have checked on this last problem. I should have checked that my solution actually worked. So I need to plug it in, and I need to actually have checked it. And then I need to check this, this solution over here. So 243 goes to the 3/5 power. This is 5th root 243 cubed, which is 4 cubed, or no, 5th root of 243 is 3. So that's 3 cubed, which is 27, which is what it's supposed to be. So, okay, this one, we were supposed to check our answer. I kind of got to the end and forgot to check it. This other one here, we're going to check, does this work, 68 and then negative 60, work for this setup here, x minus 4 to the 2/3. So if we put 68 in, 68 minus 4 is 64. To the 2/3, this will be the cube root of 64 squared. Cube root of 64 is 4. 4 squared is 16. It's supposed to equal 16, so this checks out. That one's good. Let's check this one. If I put negative 60 in there, negative 60 minus 4 is negative 64 to the 2/3. That would be cube root squared. Cube root of negative 64 is negative 3. Oops. No. Cube root of 64 is negative 4. That's squared. Negative 4 squared is 16, so this checks out. And we get both solutions. In this case, are good solutions. They both end up working. Okay. So we're going to move along to the last couple problems here. For these, what's going to happen is, well, I guess let's just do them. We got part A. We want to solve x plus 1 to the 2/3 minus x plus 1 to the 1/3 minus 2 is 0. So what we want to do is we want to make this look like something squared minus something to the first power minus 2 equals 0. Because if we can get it to look like that, and we want the same thing to be in both these parentheses, if we can get it to look like that, then we can replace the thing in parentheses with a u, and this will make it visually easier to see out factors. So an x plus 1 to the 1/3, if I have an x plus 1 to the 1/3 and I square it, that'll be x plus 1 to the 2/3. If I have a x plus 1 to the 1/3 and it's to the first power, that'll be an x plus 1 to the 1/3. So we found the thing that goes in the parentheses, so we're going to visually clean this up by letting the symbol u equal that part in the parentheses. So when we do that, we get u squared minus u minus 2 is 0. This we can factor in terms of u. So factor is u minus 2 times u plus 1. This will say u minus 2 is 0, or it'll say u plus 1 is 0. We'll let the 2 slide over, we'll let the 1 slide over. So u is 2, or u is negative 1. Well, the original problem asked me solve stuff in terms of x. I currently got stuff in terms of u, so what I need to do is I need to take what u is actually equal to and substitute that back in. So I get x plus 1 to the 1/3 is equal to 2, and x plus 1 to the 1/3 is equal to negative 1. So I need to solve each of these for x. So I'm going to cube both sides. Cube gets rid of the 1/3. We get x plus 1 is 2 cubed is 8. We'll subtract 1, and we get x is 7. Here we cube both sides. We get x plus 1 is negative 1 cubed is negative 1. We subtract 1, and we get x is negative 2. So the ones will cancel there. Okay, so the last couple that we're going to look at are going to have this same type of style where you get parentheses on stuff, get them looking like stuff squared, minus stuff to the first power, minus number, or whatever. We're going to let u be the kind of messy part, and then we'll be able to rewrite it in terms of u's, and that'll be something that's easy to factor. So for this next one, I guess part B is, what if we had 6x to the negative 2 plus an x to the negative 1 equal to 2? Now, first step, we got to slide the 2 back over to get everybody on the same side. Then we can get going on this. Okay, so I need this to look like 6 times something squared plus something minus 2 is 0. Or I guess it would be something to the first power. And if I use x to the negative 1, I'll note x to the negative 1 squared is x to the negative 2. X to the negative 1 to the first power is that. So we're going to let u equal x to the negative 1. Then that equation becomes 6u squared plus u minus 2. So I just replace the x minus 1 here and the x minus 1 here. I replace them with u's. So now I need to try to factor this result, which, let's see here, it's a 3u and a 2u. The 2u pairs up with the 2 to become a 4. The 3u will pair up with the 1 to become a 3. We want positive 4 and negative 3. So then I set each of these individually equal to 0. Get 3u plus 2 is 0. And I get 2u minus 1 is 0. So slide the 2 over. 3u equals negative 2 divided by 3. So u is negative 2/3. Here I'll slide the 1 over. So I get u is a half. u was actually x to the negative 1. So now I need to go back from u's. I need to go over to x to the negative 1 equals negative 2/3. And x to the negative 1 equals a half. We're going to raise both sides to the negative first power. X to the negative 1 to the negative 1 is just x, because negative 1 to the power of negative 1 multiply. Then that equals, when you have a fraction raised to the negative first power, you flip the fraction over. So this one becomes 2/1, which is 2. Okay, so we got one last example, and then we'll be done with the section here. So this final one, we want to do, let's see, it's 12 x to the 4th minus 11 x squared plus 2 equals 0. So I need to make this look like 12 times something squared minus 11 times something to the first power plus 2 is 0. X squared squared is x to the 4th, and we got an x squared there, so I'm going to use x squareds inside of these. So I'm going to let u equal an x squared. We'll get 12u squared minus 11u plus 2 is 0. Got to factor this. Let's see here. So that's 12u. 4 times a 2 makes it 8. 1 times a 3 makes a 3. 8 plus 3 is 11, so they both need to be negative. And what we got is 4u minus 1 is 0. 3u minus 2 is 0. Let the 1 slide over. Let the negative 2 slide over. We'll get 4u equals 1. We'll get 3u equals 2. Divide the 4. So u equals 1/4, and here we'll divide the 3. U equals 2/3. U is actually x squared, so now to get our solutions in terms of x, this is x squared is 1/4, and this says x squared is 2/3. To get rid of the square, we take plus or minus square root. So I get x is plus or minus, square root of 1 is 1, square root of 4 is 2. And over here, I get x is plus or minus square root of 2/3. All right, so that wraps up that section. So we'll stop there.